Hi guys, I hope you are all doing well. Welcome to today's class. Uh, this is Engineer Nsongo and I'm going to take you through pad footings. As you're aware, we have many types of footings when it comes to distribution of loads from our structures, and they are divided majorly into shallow and deep foot foundations. And then now when we talk about footings, they fall in shallow foundations. And examples of footings include strip footings, pad footings, and sometimes we might even go to the use of rafts when the loads are too much. And today we're just going to look at pad footings and what they do or they are, and we will size a pad footing. The contents of today's study, we are going to introduce a pad footing. What is it? What does it do? We are going to look at its key features that are supposed to be in every detail of a pad footing that you give. And then we will look at eccentricity in pad footings, that is how the loads are loaded on the footing from the columns. And then we will look at the different types of pad footings that exist, from which we will go to the sizing of a single pad footing. We will size one so that we can see the general process of designing a pad footing. Lastly, we will have a sample or structural detail of a pad footing, and I hope it will guide you as you are going to design a footing. And I have not included the video for the actual design of a footing, because I wanted us to go through this introduction so that we can design a footing manually, and then we proceed and use software so that we can compare on the modalities of using the software and the advantages and disadvantages of either doing it manually, manual design calculation from the codes, or using the existing softwares to design and detail a footing. So thank you, welcome. I hope you're going to learn a lot and it's going to help you in your life as a civil engineer or an architect. Uh, Generally, a pad footing is, we normally call it a footing simply like that, but there are different types of footings. That is why we need to attach the word pad, or sometimes we call it an isolated footing. That is a footing on its own, just as shown on this picture here. This is a type of a foundation that we use in construction to support and distribute loads from just a single column to the underlying soil. The work of footings is to distribute loads from our structures to the soil. So that is what a pad footing does. And actually, in this case, it is going to distribute load from just a single column. Though there are exceptions, as we will, when we'll be looking at the types of pad footings, we will realize that there are footings that are having more than one axle load, that is more than one column. And we are actually going to look into all that. Uh, Generally, this is a flat, either square, rectangular, or sometimes you can have even circular. I have designed a circular footing before that is made of reinforced concrete that sits underneath a column and extends beyond the column's dimensions, basically describing what a pad footing is, as you can observe from here. And then these footings are normally suitable to support isolated columns, as we have stated. And these isolated columns are normally found in structures like framed structures, where the columns are actually spaced apart. And then pad footings are especially prevalent in structures where loads are not really uniformly distributed, and individual footings are needed to support specific point loads. That is, in a structure, you can have different columns having different pad footings distributing loads to the soil. The use of these footings actually is widespread due because they are simple, they are cost effective to design and construct, and they are efficient in handling concentrated loads, like loads from columns, vis-a-vis distributed loads like loads from shear walls and normal load-bearing walls. So these are normally used for columns and they are not used for shear walls and load-bearing walls. Looking at the key features of these footings, their main function is load distribution. These footings are actually designed to distribute loads from columns evenly to the soil beneath. Uh, this helps prevent soil from being overloaded and minimizes the risk of settlement or structural instability. And actually, that is the main function of footings, whether it is a strip or a pad footing. We also need to consider the shape and the size of our pad footing. As I said earlier, it can either be square, rectangular, circular, or whichever, or sometimes they can even be trapezoidal depending on your site and your design considerations. And therefore, this size and shape is very important because how you will position your columns will also govern the shape and govern the design that you're going to apply. And then because we have talked about the material for these pad footings being reinforced concrete, therefore you need reinforcement. When detailing, or as we will see later, reinforcement is very important. Actually, pad footings are often reinforced with steel bars so that their strength is enhanced and their load bearing capacity is enhanced. This is because this reinforcement helps it to withstand tensile forces that are normally exerted on the footing. And if we have any moments on the footing, the reinforcement is what is going to take care of that. Also, depth is an important aspect when designing a footing because depth is governed by the shear resistance required and also the general utility of the structure and the axial loads of the structure and many other parameters. The depth of a pad footing is actually determined on these factors that I've mentioned, and even soil bearing capacity and the actual axial loads or design moments required. Deeper footings are typically required for larger loads, or if you have a weaker soil condition, then you might need to have a deeper and wider footing. That is why the depth and shape are important, and reinforcement together with load distribution as well. Uh, from there, we move to eccentricity in pad footings. Normally, pad footings are not only loaded on the center. Sometimes you might have pad footings that are loaded on the edge, and this is what we are going to consider in this section. So when we talk about eccentricity, pad footings can experience either concentric or eccentric loading based on how the load is applied in relation to the center of the footing. Understanding the term concentric and eccentric is crucial so that you can know which one means it is at the center and which one means it is not at the center. It has some eccentricity value. And when we talk about concentric, this means the column is at the center of the footing. And when we talk about eccentric, it means that the column is at the edge of the footing or it is moved from the center. There is some distance from the center of point of action of the load to the center of the footing. So for concentric loading, this occurs when the load applied to the column is perfectly centered, just as I have explained before, on the top of the pad footings, i.e. the line of action of the load passes through the centroid of that footing. In concentric loading, the load is normally even distributed across the entire footing, and this results in uniform stress, uniform bearing pressure on the soil directly beneath the footing. Therefore, the footing is subjected to axial compression forces without inducing any bending moment. That is why concentric loaded footings are economical to design. Concentric loading actually simplifies the design process since the footing experiences axial forces primarily, and moments are not much, or their effect is not much felt in such a footing. This design focuses on ensuring the bearing capacity of the soil is not exceeded and the footing can safely transmit the load to the ground. And I'm going to explain via the pictorial I have presented below, where I have this is a pad footing, this is the plan, and this is a 3D pictorial of the footing. So in this plan, we have the entire distance from here to here. But as you can observe, we have dimensioned the distance from the edge of the footing to the edge of the column as A, and you can observe that this distance is the same on both sides, and B is the column dimension. Therefore, if A and A are the same, it means this column has no eccentricity in the X direction. On looking at the Y direction, you also have A being equal to A. Therefore, there is also no eccentricity in the Y direction. Therefore, this footing is concentrically loaded, as you can observe from this pictorial. In simple terms, the column is located at a position equidistant from all the four edges of the footing. And sometimes if it is rectangular, you can also have the column at the center of the line of action of the footing, which means that it will also be concentrically loaded. When we come to eccentric loading, this is where now it starts becoming interesting. This loading normally occurs when the load is not centered, as I have said, on top of the pad footing, and the line of action of the load is offset from the centroid of the footing. This distance of offset is what we call eccentricity. So if you're asked what is the eccentricity of this column, you should find the distance of offset of the column from the center of the footing. This normally creates a moment. This is a bending moment about the centroid, which normally we have to design. Eccentric loading introduces both axial compression and bending moments to the footing. As we had seen earlier, when we were talking about concentric, we were just dealing with the axial compression and no bending moments. But in this case, we have introduced bending moments on our footing. The side of the footing where the load is applied experiences greater compressive forces, while the opposite side experiences tension. Therefore, that tension needs to be designed for, and reinforcement or a proper structural mechanism has to be taken into consideration. This is because there are uneven stress distribution and potential soil failure on one side as compared to the other. So designing for eccentric loading requires consideration of both axial compression forces and bending moments. That is the forces that cause bending in the footing. Therefore, as an engineer, you must ensure that the footing can resist bending moments and provide sufficient reinforcement to handle tensile forces induced by the eccentric loading. The bearing capacity of the soil must also be carefully evaluated so that you do not have a case of soil failure in your design. We therefore move to causes of eccentrically loaded footing. Why do we? Because we have seen eccentric loading comes with a bit of challenges which we need to counter in the design. This is not just because engineers decide, it is because of some cases, and we are going to look at a number of them so that you appreciate why we design eccentrically loaded footings. One of them is column placement. Sometimes there are existing underground obstructions. I'm going to give you an example. Assuming I have an underground tank that is extending into my the edge of my structure. Therefore, it means when I'm doing my pad footings at that edge, I'm going to place a column at the edge of the footing so that I don't have my footing extending to the underground tank where there is no soil beneath. Such cases call for introduction of eccentrically loaded footing. And soil variability, sometimes if the footing is so big, you might have bearing capacity varying across the building footprint. Therefore, an eccentric footing sometimes is possible so that you optimize the road distribution on the account of variation in soil support. Sometimes you have adjacent structures to your structure. If a new structure is being constructed close to existing building, or if you're building along a property line, and this is the case in many modern construction sites, because land has become so valuable that developers want to optimize on the use of land. So the architects design buildings just on the boundary line, so that they utilize natural artificial lighting or defined ways of lighting their structures, but sometimes they build on property lines. Therefore, these can call for the putting of a column on the edge of a footing. Sometimes the architectural considerations force you to do something, uh, and in such cases, maybe the building layout, design preference of the architect and the developer, and these may sometimes lead to need for eccentric. For example, if an architect desires a specific column placement that does not align with the building's center line, sometimes you might be forced to come up with an eccentric footing as the structural engineer. Lastly, we have loading conditions governing the placement of eccentrically loaded footings. Sometimes, for example, when you're subjecting a structure to dynamic loads, e.g., when you have machines in a workshop or a factory, you might be forced to place a column at the edge of a footing. Therefore, these can easily manage the dynamic loading and provide stability to your structure. Therefore, this is also good to take into consideration. And having considered that, we are going to proceed to types of pad footings. And we have very many types of pad footings, and as we continue coming up with new innovations, as the structural engineer, you can study the material properties of structure, the shape, and come up with appropriate ways to counter forces and moments, because that is what we are designing for in all the days. Therefore, these are just the basic ones that have been existing over the years, but we have very many more types of pad footings. The very first type is the single pad footing. A single pad footing is actually the most basic one, and if you have been to a construction site where you have a frame structure, you must have used a single pad footing. This consists of a single footing that is centrally loaded, and it can be square or rectangular, and it supports a single column, and it is suitable for structures with very light loads. Like when you're doing mansionettes, you will use this structure most of the time. Sometimes now you can have a footing that is stepped. This is called a stepped pad footings, and it is actually designed with multiple levels of steps, as you can observe from this plan view or this pictorial provided right here. This is actually useful when the bearing capacity of soil varies at different depths, and each step might support a different load. Or sometimes, when you want to do an economical design, maybe the shear at a distance d from the face of the column is very high, so you might want to take care of that shear using a stepped footing. And all these are decided by the engineer doing design, but of course there must be governing laws as stated in the codes. And this is actually economical because assume this engineer realized that he needs a depth of 1 meter, and this depth is most critically needed at this point. So, and if we have maybe 400 millimeter at this point, it is still okay. So you can do a step footing, and it will take care of the shear at that point. And sometimes you can even concrete this entire section so that you can have a sloped footing, one that is sloped. This takes care of concentrated shear at just at this column junction. And there are two types of shear it takes care of. One is shear at the face of the column and shear at a distance d from the face of the column, which are governed very well by the codes. Next, we have a strap footing. A strap footing is actually a combination of two or more footings. So I don't know whether these can be classified as a pad footing, but it combines two pad footings. These footings are normally connected by a beam. This beam is called a strap beam, hence the name of the footing as a strap footing. This is normally used when loads from individual footings are not uniform, or when these footings are too close to each other, so you connect them. Or sometimes you are building maybe on a property line and your footing is eccentrically loaded, so you tie a strap beam so that you can take care of the excessive bending moments that have been introduced in that footing. And this is very common for clients who build on boundary lines. Next, we move to combined footings. Combined footing is actually similar to a strap footing, but it is a pad footing distributing load for more than one column. It is uh, just one footing, but supporting more than one column. Sometimes it can support two columns, three columns, or four columns. And if one footing supports so many columns, we cease to call it a pad footing. Now it becomes a raft or a mat foundation. But if we have one footing supporting more than two columns, and just very few, maybe two or three, it is called a combined footing. And the combined footing can be designed, these are trapezoidal combined footing, and this is a rectangular combined footing. They can be designed depending on the loading, axial loading from the columns. And in this case, this shows that loadings from these columns are relatively uniform. That is where we have a uniform footing. But this one, being trapezoidal, it shows that you have this loading in this column is much more than this one. Therefore, the footing has to be wider at this section as compared to this section because it is supporting more load at this point. Sometimes we actually necessitated to use combined footing because of closeness of columns. The columns are too close to each other that if you have two separate pad footings, they overlap. So you do a combined footing instead. Now, having talked about the types, these are just basic types that we will encounter on any site if you have been construction sites. And there are much more. You can come up with your own depending on which load or which moment you want to counter in your site. Now we are about to finish, but I realized just talking about footings without doing any math will not be engineering. Otherwise, we could be out there studying something else. But how do you now size a pad footing? It is very basic. The very first step before you do anything in terms of design or analysis, you're supposed to go to site, study your soil conditions, and determine the soil bearing capacity. Because this is a shallow foundation, we don't need to do rock coring to determine the type of material way below the surface. We just need to determine the soil bearing capacity at the surface, where at the invert surface where our footing is going to lie on. Sometimes we might be forced to study the soil below, but this capacity is the capacity at the point, the allowable bearing capacity at the point where your footing is going to rest on the ground. Then after determining the soil bearing capacity, in most cases, for instance, when we do design of mansionettes or very light structures, sometimes we don't determine the bearing capacity. We might look at the soil. We dig trowel pits to get to the surface, and we look at the soil and assume a tentative allowable bearing capacity that we can use for our design. This is not a very good practice, as many engineers run away from doing this geotechnical investigations. But sometimes you can just also from experience, being that the loads are not so big, you can assume a tentative value for bearing capacity of your soil. Second, you also determine your serviceability limit state loads. Remember SLS loads. What are SLS loads? SLS loads are loads that have not been factored by any factor. Means you just take the dead loads as they are from the building, and you add them to your live loads, and you add any other load that the building or the structure will be subjected to while in its service conditions. That is why SLS means serviceability limit states, so that you get the actual load, maximum load that your structure is going to withstand. After determining the SLS and you have, of course, your bearing capacity, then you determine your footing area. How do I get the footing area? To get the footing area, you take the total serviceability limit state load and you divide that by the allowable soil bearing capacity. This one will give you a value, and the value you'll get will be in meters squared, and this will be your footing area. And then you select a suitable shape. If you want a square footing, a rectangular, trapezoidal, whichever it will be, you assume that that shape that you've chosen bears the area that you have obtained in step 3 above. Now, when you move to step 5, in step 5, you determine the footing dimensions. If it was a square, you just need to get the square root of the area you found above, and you will get the length of your footing. Remember, the most important formula here is footing area, which is the total SLS load divided by the allowable bearing capacity. Now let me jog your minds a little. Why do we use SLS loads as opposed to using ULS loads? ULS are ultimate limit state loading. This means you have your loads, but they have been factored. Why? Remember, depending on the code you're using, sometimes if you're using the Eurocode, you might need to do for dead load, you do 1.35, and then for live load, you use 1.5. And then for British standard, for dead load, you use 1.4. For live load, you use 1.6. And then sometimes you might need to do earthquake loads, wind loads. There is also a combination where you can do 1.2 dead load, 1.2 live load, 1.2 earthquake load, 1.2 wind load, and so on and so forth. So depending on your load combination, if you include the factors, it becomes ULS. If you exclude the factors, you just take the load the way it is in the serviceability state of the structure, it becomes SLS. Therefore, why do we use SLS when sizing? Remember, I have not talked about design of the footing. Why do we use SLS? That is a question to think about. Number 2, we have talked about the sizing of a pad footing, and we have sized just the plan area. What about the depth? What do we do when we are sizing the depth of a pad footing? In our next session, we're going to look at the design of the footing. That is where we're going to answer all these questions. But let me answer one for you, and you will answer the other one in the next class. Why do we use SLS loading instead of ULS? When sizing a pad footing, both the serviceability limit state and ultimate limit state loadings are considered in the overall design process. However, SLS loadings take precedence during the initial stages of sizing. Why? Due to its focus on ensuring the structure's serviceability and functionality without causing excessive deflections or deformations. Sometimes we size a footing using SLS, and when we are carrying out these checks, we realize serviceability and ultimate limit checks, we realize that it is not meeting condition. So it forces us to increase the size or increase the depth or whatever we desire, or use better or bigger reinforcement. During the initial design phases, engineers often start by considering SLS loading to establish the basic dimensions of the structural elements, such as pad footings. This allows for a more realistic assessment of the structure's behavior under service conditions. This is our main term, under service conditions. Once the pad footing is sized based on SLS loading, additional checks are conducted to ensure that the design also satisfies the ULS requirements. And the ULS is what we use now to design for the moments and any tension that might be existing in our footing. And these requirements focus on the structure's ultimate strength and safety. Now we're talking about ULS. ULS considerations involve verifying that the structure can withstand the maximum applied loads without failure. So if you size using SLS and you apply the ULS considerations and you carry out the checks and it fails, then you have no otherwise other than to resize your footing. So having talked about that, we now move to a sample structural detail of a pad footing. So this is a sample detail of a pad footing, and I'm going to start by talking about the labeling. When you're labeling this is a plan. When you're labeling a plan, it is expedient you tell us the size of the element that the footing is supporting, that is the column. So in this case, we have a 400 by 200 millimeter column on. Now we are going to the details of the footing. 1600 by 1600 by 400 millimeter pad footing. And this base is base number 2. That will be in our foundation layout. And how many are they in number? They are 16 in number. This information is very expedient when calculating takeoff sheets or determining the quantity of material to buy and so on and so forth. And then, of course, you indicate your drawing scale. Also, you have to dimension it well so that we clearly see where the footing is. And in this case, the footing is at the center of the pad footing. And also, you indicate reinforcement details. And in this case, you have 8 to 12. That is 12 millimeter bars. They are 8 in number. This is the barcode, and they are spaced 200 millimeters center to center, and they have been dimensioned as bottom 2. And then in this other direction, you also have 12 millimeter bars. They are 8 in number. This number is the same because the pad size was also the same, and this one was bottom 1. And remember, hope you remember the rules of naming or labeling. Bottom 1 at the bottommost bar, bottom 2 are the second bottom bars from the bottom, and this is how you basically detail a pad footing. And then this is the plan view. So you also do ideally we do a section on top of the plan view so that we can see the details clearly, but I've done it here. So on the section, you have to indicate the section. You have to show clearly the barcode so that when I go to the plan, I can look for the barcode. This barcode also help us when we are doing bar bending schedules so that we get the code of the bar to help us determine which bar to bend. And you also dimension it clearly. You have 50 millimeter blinding at the bottom of your footing, and then you have this depth. You also indicate that depth will be determined on site and a minimum of 1500 millimeters. From there, you show us how you will tie your links. The number of links here, we have 8 millimeter bars, barcode 3 tied at 125 millimeter spacing. And the starter bars of your column are also indicated here because once you tie the reinforcement for a pad footing, you also tie the reinforcement for your starter bars because you will concrete. The first concreting will happen when the reinforcement of the starter bars of the column have been indicated. And then, of course, you show the connection at the lapping section, and you show the lapping distance of your reinforcement. Therefore, basically, this is how you detail a section of a footing. And depending on whichever software you're using, sometimes it may not appear as this one, but it bears all the information that you need. And also, as you've noticed, we don't have top bars for our pad footings. So another question, remember today I'm leaving you with 2 questions. We had actually 2. I talked about why do we use SLS loading, and I have explained that here. And then there was the second question. Which one was it? Yes, how do we determine the depth of our footing? So I'm going to leave you with two questions to think about and keep researching. But when we're designing this footing, we will show you, uh, uh, we will answer those two questions. So question number one to take away home is, how do you determine what governs the depth of a footing? Question number two, is this proper, as we have reinforcement at the bottom section and there is no reinforcement at the top section? What is the purpose of the top reinforcement that we put in pad footings, and which cases necessitate that? So that is the end of our study today, and I hope you have learnt a lot. Just show you the contents. We dealt with the introduction, we looked at the key features of our pad footings, and we talked about eccentricity, types of footings. We went through a process of sizing a pad footing, and now lastly we looked at the sample structural detail of a pad footing. Therefore, thank you very much for you have joined us today. I hope this information is going to be helpful so that when you want to quickly size a footing or tell which footing should be required where, you can get the information from here. So I want to thank you all, and I hope that next time we will talk about the actual design of a pad footing. Continue subscribing and continue uh, giving word out there that we do this. If you need if you need us to design for you a pad footing, you can contact us through the details provided here. We have our email address and our contacts so that we can guide you through the process. And actually, we have a number of sites going on. So one of these fine days, I'm going to show you how this steel fixing is done on site and how you concrete pad footings on site. So thank you. May the good Lord bless and keep you. Adios.